In this video lecture, I will assign the loads to the space frame that we modeled in our previous lecture as per ASCE 702 code. And I will also define the load combinations. ASCE 702 code is the older revision of the ASCE 716 code, which is the latest standard as per ASCE. So for the students who don't know about ASCE, I will tell you something about ASCE. So the ASCE is the American Society of Civil Engineers. It is a tax-exempt professional body, was founded in 1852 to represent the members of civil engineering profession worldwide. Headquarters of the ASCE is at Reston, Virginia in the United States. ASCE is the National Engineering Society in the United States. And ASCE is the constitution which was based on the older Boston Society of Civil Engineers from 1848. So this is whole thing about ASCE. So in this video lecture, we will assign the loads to the space frame and we will also define the load combination as per ASCE code. So let's get started to the lecture. So as we have modeled the space frame in our previous lecture, now we need to assign the loads over it. So the loads may be of superimposed dead load, live load, earthquake load and the wind load. So as per the ETABS checklist, here the step 6 is nothing but the define load patterns. As we know, when we do our work in the computer software ETABS, then first of all we need to define the load pattern. That means we need to tell the software that this load is which type of load. So in the step 6, we will first of all define the load patterns for the different load cases. So I will define the dead load, superimposed dead load, live load, wind loads in the both direction and the earthquake load in the both direction. So these are the load cases. So for that load cases, first of all we need to define the load patterns. So to define the load patterns, go to define and click on load patterns. So by default in the ETABS software, the dead load and the live load patterns are generated. So now let's define the superimposed dead load as per checklist. Give the name as SIDL and select the type as super dead and make sure the self-weight multiplier should be 0 and click on add new load. So here the superimposed dead load pattern is now generated. So now let's define the wind load in X direction and in Y direction. So first of all, let's define the wind load in the positive X direction. So for that, WLX and the type should be wind and self-weight multiplier should be 0 and the autolateral load, that is code for this type of load, is as per ASCE 702 and click on add new load. Similarly for the wind load in the positive Y direction, I will give the name as WLY and type as wind and the autolateral load as ASCE 702. Click on add new load. Similarly also we need to define the earthquake load in positive X direction and earthquake load in the positive Y direction. So ELX and type as seismic and code is also the same, that is ASCE 702. Click on add new load and same the case for the earthquake load in the positive Y direction and the type as seismic and the autolateral load is same, ASCE 702. Click on add new load. Now we need to input the data for the lateral loads, that is wind load and earthquake load as per ASCE 702. Because the American codes are not free as in India, under the Right to Information Act, the Indian standards are freely available to download from the internet. So here I can't show you the copy of ASCE 702 code, but I will tell you what are the parameters I have considered. So to modify the wind load in the X direction as per ASCE 702 code, click on modify lateral load. So now this window will open and here we have the couple of options. Now let me show you the different load parameters as per ASCE 702 code. So first of all, let's see the wind load parameters as per ASCE 702 code. So here you can see, here in this ETABS window, here we have a couple of options. So wind load pattern can be defined as per exposure from extent of diaphragms and exposure from frame and shell objects. So here I am go with the exposure from frame objects because here it is an open space frame structure. So in this structure, here we have the open frame structure. So I will select this point, that is include frame objects with open structure. So as we are here going to define the wind load in the X direction, so the wind direction should be 0 degree. Whereas here as per the structure location, define the wind coefficients and these other data. So at the location where structure will now constructed, the basic wind speed is around 44 to 45 meter per second. So if we convert these into the miles per hour, then we got the value as 100 miles per hour for the wind speed around 44 meter per second. So here I will input the wind speed as 100 miles per hour. Exposure type. So for the exposure type, we need the ASCE 702 code. But because of the restrictions of copyright, I will only explain you the terms. I will not able to show you the code. So the wind speed be 100 miles per hour. The nearby area of our structure is flat grassland area with scattered obstructions having the heights generally less than 30 feet, which is equal to near about 9.1 meter. So as per these conditions, as per ASCE 702 code, we are come under the exposure type C. So that we need to here the select the exposure type as C. Importance factor. So importance factor is depend upon the occupancy of the structure. So importance factor. So here as per ASCE 702 code, importance factor for our structure will be 1.2. That I will be discussed later when we define the earthquake load. Topographical factor 1, gust factor 0.85, directionality factor 0.85, and solid to the grass area ratio is 0.2. These are the standard values. I don't want to make a change in these values. So exposure heights are here. The top story is the top of the space frame and the bottom story is the base of the space frame. So this is all about the wind load in the X direction. Now left click on OK to save the load pattern. Similar the case for the wind load in the positive Y direction and click on modify lateral load. Same the case here, we also need to consider the exposure from frame and shell objects and check the include frame objects as the open structure. As here we are defining the wind load in the Y direction, so the wind direction should be 90 degree. And as per the wind speed of near about 44 meter per second, so as per miles per hour, it will become the 100 miles per hour. So input it as 100 miles per hour. Exposure type as C because obstructions of about 30 feet in nearby area. Importance factor as 1.25. Topographical factor as 1, gust factor 0.85, directionality factor 0.85, and solid to the grass area ratio as 0.2, and the exposure height as the top of space frame and the bottom story as the base of the space frame. Left click on OK. Now let's modify the earthquake load in the X direction. Left click on the modify lateral load. So as we have here defining the earthquake load in the X direction, so other than the X direction, another direction should be unselected. And here for the time period I will go with the program calculated. That means the computer software will calculate the time period of the structure by itself, and the story range is the top to the top of space frame and the bottom story is the base of space frame. So for the seismic group and the seismic coefficient and the response modification factor, we require the ASCE 702 code. But I will show you some parameters. Earthquake load parameters as per ASCE 702 codes are as following. So first of all I will show you the site type, that is site class. So here on the site as per the geotechnical data report, I have got here the type of soil as the very dense soil and the soft rock. And for these type of soil as per ASCE 702 code, the site type, that is site class, is C. So here we need to choose the site class as C, whereas our structure is the space frame which is of steel. So for the steel eccentrically braced frames and the moment resisting connections at the columns away from the links, the response modification factor R is 8. Whereas for this system, in the system overstrength factor omega is 2 and the deflection amplification factor CD is 4. So now I will discuss on the category. So the category will depend on the nature of occupancy. So in this space frame structure of workshop, so as per American standard, this is the building and other structure that represent a substantial hazard to human life in event of failure, because the huge machines will be placed in the workshops, so that causes these building in these category. And for this type of structure, the category will be 3. And for this category, with respect to our condition as per ASCE 702 code, our structure will fall into the H22 and F22, that is hazardous to and functional to case. Because of these conditions, will come under the seismic group 2. And as per the seismic group 2, we got the occupancy importance as 1.25. That will be also followed as for the wind loads. So here the seismic group should need to be considered as 2 and the occupancy importance as 1.25. So here, as per ASCE 702 code, as our structure conditions, we need to here select the seismic group as 2, and the seismic coefficients as per code, here we need to enter the site class as C for the very dense soil and soft rock, that is C here. So SS is nothing but the map maximum considered earthquake 5% dam spectral response acceleration at the short period, and S1 is the map maximum considered earthquake 5% dam spectral response acceleration at the period of 1 second. Response acceleration SS is 1 and response acceleration S1 is 0.4. I am not changing these SS and S1 values because for understanding of these values we need ASCE 702 code, and because of the copyright I cannot show you the code. So for the actual values of SS and S1 we need the map of America as per the ASCE 702 code, and with respect to that we need to consider that. So I will here go with the default values, and because here we have selected the per code seismic coefficient, so here the FA and FV values are fixed, that is 1 and 1.4. If you go with the user defined, then you can change that values also. So under the factor, here we have response modification factor R, which has the pre-default values 8, whereas as per our condition, that is the steel eccentrically braced frames moment resisting connections at the column away from the links, the response modification factor is 8. So here it is OK. So here the earthquake load for the X direction is now defined as per ASCE 702 code. Now left click on OK. Similarly, we need to make a changes in the earthquake load in the Y direction as per ASCE 702 code. Click on the modify lateral load. So as this load pattern is for the earthquake load in the Y direction, so unselect the all other directions and eccentricity also. Here I am also go with the program calculated time period, top story as the top of space frame and bottom story as the base of space frame, seismic group as 2, seismic coefficients as per code, site class as C for the very dense soil and the soft rock, SS is equal to 1, S1 is equal to 0.4, and the response modification factor R is equal to 8. Left click on OK. So here in the way we have here defined the all different types of load patterns. Now left click on OK. So here in the way the step 6 is completed. So here by defining the different parameters as per ASCE 702 code, here the software will get the loads for the wind loads and the seismic loads. Whereas while defining the section properties, we don't change the property modifier for the wind. So by default it is 1. So dead load will also be considered by the software itself. So now only we need to assign the loads for the superimposed dead load and live load. So before that we need to set load cases names. So for that go to ETABS, define load cases, and here you can see for the dead and live, here are the names as per the load patterns. So click on modify and rename as DL, left click on OK, and also do same for the live load, LL. Because these names will shown in the load combinations, and when we design our structure we see the load combination, and at that time it will get some uniformity in the names of the load cases. So for that reason I have here they rename the load cases. Left click on OK. So here in the way step 7 is also completed, that is set load cases, in which we rename the load cases names for dead load and live load. Now let's move to the step 8, that is assignment of the loads to the structure. That is, we need to assign the superimposed dead load and the live load, because the other loads are considered by software itself, because we have defined the parameters for them. So now let's assign the loads to the space frame. So here we are going to provide a shade over this space frame as a roof. So for that here we need to assign the loads. So for the superimposed dead load of the shed, I will assign the joint load at each joint at the top of the space frame of 1.25 kN, and for the live load for the maintenance purpose I will assign the 1.5 kN of live load. So to select the all joints at the top of space frame, I will go to the plan of the top of space frame, click on apply, click on OK. Now make sure the one story option is selected. Select the whole structure by dragging the cursor. Now here you can see 625 joints and 1200 frames are selected. If you are uncomfortable with these 1200 frames selected, go to select, deselect, object type, and select here the beams. and click on deselect. Now here you can see only the 625 joints are selected. If I can show you in the 3D view, here you can see, I will rotate the structure. So here you can see in the 3D view, all the joints at the top level are selected. Click on the 3D view. So now to assign the joint load to this joint, click on assign joint load and force. So this window will open. So first of all, let's assign the superimposed dead load. So for that, choose the SIDL, and here we are going to apply the shed load as the superimposed dead load of 1.25 kilonewton at each joint. So in the global Z direction, the force should be applied as minus 1.25, which is in kilonewton. Here you can see, because here we have selected the unit system as metric SI. So after applying the load, it will automatically apply at all joints that we have selected, that are 625 joints which are at top level of the space frame. Now click on apply. Now as you can see, at top of space frame at all joints, 1.25 kilonewton of superimposed dead load is now applied. So similarly, at the same joints, for the maintenance purpose, we need to also define the live load. So for that, so similarly, at all the joints, for the maintenance purpose, over the shed, we need to also provide the live load. In these all 625 joints that we have previously selected, over which also we need to apply the 1.5 kilonewton of live load. So to select that previously selected joints, go to select and click on get previous selection. So in the way, here you can see 625 joints are now selected. That are the joints are at top of space frame. Now select the load pattern as live and apply the load of minus 1.5 kilonewton as the live load. Now click on apply and click on OK. Now if I zoom to the structure, so here you can see the 1.5 kilonewton of live load is now applied at each joint on the top of space frame. So here in the way, we have successfully applied the superimposed dead load and the live load to our space frame. So the step 8 is also completed. So now the last step that we perform in this lecture is the defining the load combination as per the codal provisions. So here in ETABS, for the American standards, the ETABS will generate all the load combinations from the design point of view and also from the serviceability point of view. So to define those load combinations, go to define, click on load combinations. So here you can also go through and you can also define manually the load combination as the load combination type as linear add, and by selecting the load cases you can also make the load combination. But here I am go with the default design load combination and click here on the steel frame design and click on the convert to user combinations. So that makes the load combinations editable. So click on OK. So here you can see the 20 load combinations are generated, whereas these 18 load combinations are for the design of the structure, that is which are ends with S1, S2, S3 etc. to the S18, whereas these top 2 load combinations which are ends with the D1 and D2 are from deflection point of view, that are for the serviceability load combinations. If you want to create an envelope, you can also create an envelope, but I will not here creating an envelope, because whenever we design the structure as per American standards, then under the design option, we got the option for the load combination from the strength point of view and the deflection point of view. So click on OK. So as per checklist, the step 9 is also completed. So in this video lecture, we have completed the step 6, step 7 and step 8 and step 9, which are related to the loadings to the space frame. In the next video lecture, we'll see the step 10 and step 11, which are related to the analysis of the space frame.